Solving quadratic equations using the zero product property is a second strategy that we have for solving quadratic equations. We have previously solved quadratics using square roots, and this strategy of solving using square roots is a great strategy when we have an x squared or an expression squared in our equation. However, this strategy does not work when we have a linear or an x term in our equation. So this is an example of an equation we cannot solve using square roots. X squared plus 11x plus 24 equals 0. We could subtract 24, but we don't know how to take the square root of x squared plus 11x. So we're going to solve this equation using the zero product property. The zero product property states that if a times b equals 0, then a equals 0 or b equals 0. So if we're multiplying two factors, a and b, if their product is 0, then at least one of those factors must equal 0. An important part of this property is making sure that in fact we are looking at an equation that equals 0. So in order to use the zero product property to say that one of the factors is 0, the equation itself must equal 0. And that is a requirement that has been met in this equation. If we did not have equals 0 on one side of our equation, we would need to transform it so that we did have equals 0. Now we're going to solve this equation using the zero product property. The first step of this is to write the left-hand side in factored form. Writing this left-hand side in factored form is just what we did in our polynomial unit, looking for the factors that multiply together to give us x squared plus 11x plus 24. In order to do that, we need to find those two numbers that multiply to 24 and add to 11. Many of you can find those two numbers without the diamond at this point, and that's fine. But if you find the diamond helpful, awesome. The two numbers that multiply to 24 and add to 11 are, yes, 8 and 3. So 8 times 3 is 24, and 8 plus 3 is in fact 11. So now I'm going to write this left-hand side in factored form, meaning x plus 8 times x plus 3. Factored form, meaning if I were to multiply x plus 8 times x plus 3, using that distributive property, that would simplify to x squared plus 11x plus 24. Now the left-hand side is in factored form, but I need to not forget to write equals 0, because that is the equation that I'm solving. I've factored the left-hand side expression in order to solve this equation. Since I have equals 0 in my equation, this is where the zero product property comes in. If this factor, x plus 8, times this factor, x plus 3, equals 0, then either the factor x plus 8 equals 0 or the factor x plus 3 equals 0. The zero product property, which I call the ZPP, allows me to write two equations, setting each factor equal to 0. So either x plus 8 equals 0 or x plus 3 equals 0. I then need to solve each equation. X plus 8 equals 0 is an awesome one-step equation. When I subtract 8 from both sides, I get my first solution. X equals negative 8. Using inverse operations to x plus 3 equals 0, I get my second solution. X equals negative 3. My two solutions to the equation x squared plus 11x plus 24 equals 0 are x equals negative 8 and x equals negative 3. I can verify that that's the case by plugging the value of x back into the equation and making sure that I get a true statement. So does negative 8 squared plus 11 times negative 8 plus 24 equal 0? I sure hope so. So negative 8 times negative 8 is 64. 11 times negative 8 is negative 88. Does 64 plus negative 88 plus 24 equal 0? 64 minus 88, negative 24, yes! Negative 4 plus 24 does equal 0. So what I've done here is verified that negative 8 is in fact a solution to this equation. If I plug negative 3 in, I am similarly able to verify that negative 3 is a solution. Negative 3 times negative 3 is 9. 11 times negative 3 is negative 33. And 9 plus negative 33 is negative 24. So does negative 24 plus 24 equal 0? Yep. So x equals negative 3 is my second solution to this equation. Here is a second example. X squared plus 2x minus 8 equals 0. First thing that I am verifying, my equation has to equal 0. If my equation does not equal 0, I cannot use the zero product property. So I have met that requirement. First step is to write the left-hand side in factored form. What two numbers multiply to negative 8, and add to positive 2? Those two numbers are 4 and negative 2. 4 times negative 2 is negative 8. 4 plus negative 2 is positive 2. So I'm writing that left-hand side in factored form. Not forgetting to write equals 0 because that is the equation that I'm solving. Now I know that if this factor times this factor equals 0, either the factor x plus 4 equals 0 or the factor x minus 2 equals 0. Now all I have to do is solve each equation. So my first solution is x equals negative 4. If I plug negative 4 into this equation, I will get 0. Solving the second equation, I get x equals positive 2. If I plug 2 into this equation, I will get 0. So I have solved my second example. The two solutions to x squared plus 2x minus 8 equals 0 are x equals negative 4 and x equals 2. Now something awesome about solving quadratics using the zero product property is discussed here. The solutions to the equation solved using the zero product property give me the x-intercepts of the function obtained from the left-hand side of my equation. So let's look at what that means for this example. So let's write the function obtained from the left-hand side of this example. So f of x equals x squared plus 2x minus 8. So when I look at this function, when I solve this equation, what I'm finding are the x-intercepts of this function. This function, f of x equals x squared plus 2x minus 8, is graphed right here. And you can see that, in fact, I have found the x-intercepts of this function. The first x-intercept is 2, 0, and the second one is negative 4, 0. So x equals negative 4 gives me the x-coordinate of my x-intercept. X equals 2 gives me the second x-coordinate of my second x-intercept. Notice that the reason that this is the case is that the x-intercepts are the 2 points where y are 0. So when y is 0, that is telling me that the output is 0. And that is exactly what I'm finding by solving this equation. The two input values that give me an output of 0. So f of negative 4, when I evaluate the function for negative 4, I get 0. When I plug in 2, I also get 0. And that means, again, when I solved this equation, I obtained the point, negative 4, 0, 2, 0, the two x-intercepts of the quadratic function obtained from that equation.